In this video, we're going to go over Module 2, Topic 2, Lesson 1. So it says a power function is a function of the form p of x equals a times x to the n power, where n is a non-negative integer. The degree of a polynomial is the biggest variable exponent in the expression, and the leading coefficient is the coefficient in front of the variable with the biggest exponent. So in that ax to the n power, the degree of the polynomial would be n, and the leading coefficient would be a. So in this first example, it says identify the degree and the leading coefficient. So the degree is the biggest exponent. If we're looking at this, our biggest exponent that we have is a 4. So this is a degree of 4. Then we look for the leading coefficient. That's the number in front of the variable with the biggest exponent, and that is -4. Looking at letter B, we see that our biggest exponent is 5, so it is a degree of 5, and our leading coefficient is 8. Looking at letter C, the degree of the polynomial is 3 because that is the biggest exponent, and our leading coefficient is -9 because that is the number in front of the variable with the biggest exponent. Now, the degree and the sign of the leading coefficient determines how the ends of a polynomial behave. Okay, so this allows you to get an idea of what the ends of the polynomial are doing without having to graph the polynomial. So this is called the leading coefficient test. Okay, the leading coefficient test is a way to determine how the ends are behaving without needing to graph the polynomial. So we have odd degrees and even degrees. We have positive leading coefficients and negative leading coefficients. So with an odd degree, what we need to know is that our ends are going in the opposite direction. So ends go in opposite direction. Okay, so when you have an odd degree and a positive leading coefficient, that means that your right side will go up. So positive leading coefficient tells you about the right side. So this means that the right side goes up. Well, if it's an odd degree and the right side's going up, that means the left side has to go down. Now, we don't know what's happening in the middle of the polynomial. It could do something like this. Okay, it could just go like that. We have no idea. But what we know for sure is that the right side goes up and the left side goes down. Now, if we have an odd degree with a negative leading coefficient, how that's going to change your graph is now the right side will go down. So what that means is this side is going down, which means if it's an odd degree, the left side has to go up because they go in opposite directions. Okay? Now, we do have even degrees. So even degrees, the ends go in the same direction. So if we have an even degree with a positive leading coefficient, the right side goes up, and since it's even, so does the left side because they match. Okay, if we have a negative leading coefficient with an even degree, the right side's going to go down, and the left side is going to go down because we have an even degree. So this just tells you about the ends, so it makes it easier to graph the functions or match a graph based on just the ends. Okay, so in example 2, it says match the polynomial equations to their graphs using the leading coefficient test. So here we go. First thing we want to identify is what is our degree. Our degree in this case is 2, so our degree is even. Then we look for our leading coefficient. Our leading coefficient is 3. 3 is a positive number. So we have an even degree with a positive leading coefficient. Now, with even degrees, they can either both be going up or they could both be going down. How you determine it is based on the leading coefficient. So the leading coefficient is positive. We want the right side to go up, so that means they're both going up. So then we look down here and we look for a graph that has both ends going up. And if you look at graph B, it has both ends going up. So graph B would be the graph that goes with our equation P of x. Now, if we look at number 3, what is our degree of number 3? The highest exponent is 3, which means our degree is odd. Then we look for our leading coefficient. Our leading coefficient is the number in front. Now, remember, there is a 1 attached to that, but what really matters is that our leading coefficient is negative. Now, with odd degrees, you can either have it going down and up, or you can have it going up and down. How you determine is based on the right side. Well, since our leading coefficient is negative, we want the right side to be going down, so we want this one right here. So we need a graph that has the right side going down, but the left side going up. So if we look at our graphs, notice that on A, the right side is going down and the left side is going up. So graph A would match with number 3. Okay, looking at number 2, again, you start by looking at the degree. The degree here is 2, so that is an even degree. Remember, even degrees either both go up or they both go down. Then we look at the leading coefficient. So our leading coefficient here is a -1. So that means that our leading coefficient is negative. So when our leading coefficient is negative, we want the right side to go down. So we want them both to go down. So now we're looking for a graph where they're both going down. So that would be this graph here and this graph here. So that would be letter C. Okay, number 4, looking at the degree. The degree is 3. So that means that we have an odd degree. So that means we want our ends going in opposite directions. Then we look at our leading coefficient. That would be a 1. And so that means it is positive. So when it's positive, we want the right side to go up. So that means we want this. So if we look at our graph, we only have one graph left, but just to make sure it confirms and matches what we've been saying, the right side is going up, the left side is going down. Therefore, D is a correct match. Now, the purpose of this is so you don't have to graph it in the calculator. It's something that is supposed to be quick and easy to identify. Okay, now the next part we're going to talk about is even and odd functions. So even and odd functions are different than even and odd degrees. Okay, so we got to make sure we keep them separate. Now, an even degree can be an even function, and an odd degree can be an odd function, but it doesn't have to be. So what is an even function? An even function is something that is graphically symmetric over the y-axis. The y-axis is the line x equals 0. So what that means is if you were to fold it in half on the y-axis, everything on this left side right here is going to line up exactly with everything on this right side. It is perfectly symmetric. Now, this also happens to be an even degreed function because both ends are going in the same direction, okay? But an example of something that is an even degree function but is not, or an even degreed function but not an even function would look something like this. So you could have a graph that maybe looks like this, okay? That is an even degree, but it is not an even function because it does not have y-axis symmetry. Okay, the left side is not identical to the right side. So this right here is an example of something that is not an even function. Okay, now when you're looking at the equation of an even function, the equation of an even function will only have even exponents. So 2, 4, 6, 8, 10, and it can have a constant, okay? It can have a constant. So you have two different examples, one with a constant, one without a constant, to show you what the equations could look like. So when you're looking at equations to determine if they're even or odd, you're going to look at all of their exponents. So in this first one, we have 4x to the fourth minus 6x to the second plus 1. So 4 as an exponent and 2 as an exponent are even numbers. And then this plus 1 is the constant, which again, constants are okay. Okay? If we look at our second equation, we have f of x equals 7x to the 8th minus 4x to the 6th plus 2x to the 4th. Again, it's an even function because our exponents are all even. So if we were to graph this, they would have even symmetry along the y-axis. So let's see if we can graph one real quick. We're just going to graph one of them so you can see. So we have 4x to the fourth power minus 6x squared plus 1. So notice, let me zoom a little bit. Notice right here, this is symmetric about that y-axis. Everything on the left side is matching everything on the right side. So that's just to show you all even exponents and a constant works, okay? Now, on the other side, we have odd functions. Odd functions are graphically symmetric about the origin. That is the point 0, 0. So if we're looking here, 0, 0 is here. And so when something has origin symmetry, the diagonal quadrants are going to match. So that means that this quadrant right here is going to be identical to this quadrant right here. Okay? And then this quadrant here is going to be identical to this quadrant here. So if we kind of color coordinate this so we can visually see, notice that the first quadrant has this little maximum, and down here it has that same one, but it's just flipped. Okay? Then it also has this part in quadrant 4 and this part in quadrant 2. They are identical. And then lastly, we have this part that ends in quadrant 1 and this part that ends in quadrant 3. They are identical. So notice that quadrant 1 and 3 have the same two parts of the graph, and quadrants 2 and 4 have the same part of the graph. That's how you know it has origin symmetry. Now, this happens to also be an odd degree because our ends are going in opposite directions, okay? But not all odd degrees are odd functions. So an example of a graph that is not an odd function would be something like this, okay? So that is an odd degree because the ends are going in opposite directions, but it does not have origin symmetry. So this piece right here is not in this graph down here or in this quadrant down here. So this is an example of something that is not an odd function, but it is an odd degree, okay? Now, with odd functions, how you know from an equation is that all of the exponents will be odd. Only odd numbers. You cannot have a mix of even and odd. Even and odd is neither. Okay, but every exponent is odd. And the one important thing about this one is that it can have no constants. A constant will mess up its symmetry. Okay, so an example of what this looks like is 5x to the 7th, 12x to the 5th, negative 14x to the 3rd, and 7x, which is 7x to the 1st. Okay, so making sure that you pay attention to the exponents. The number one mistake I see people make is that they forget that this is an exponent of 1, and they just think of it as an even number when it's not. Now, something that would make this not an odd function is if there was a plus 3 here. A plus 3 would make it not an odd function because that's the constant. So remember, these cannot have any constants. So to look at Desmos, just so you can see, I'm going to type that in. Okay, so let me zoom out just a little bit. There's the graph of it. Notice that it is symmetrical. Everything in that first quadrant is matching everything in that third quadrant. There's nothing in quadrant 2 and 4. Okay, and look and see what happens when I say plus 7. Okay, now that didn't change a whole lot. It doesn't look like it changed a whole lot, but it did end up messing up with the thing. And it's because, let me zoom in a little bit more. There we go. When I have that plus 7, notice it shifted it up 7. Versus when I take the 7 off, okay, now it's more identical in the quadrant. So zooming in may be beneficial. I was zoomed out too much so you couldn't see a change. Okay, so again, when you add a constant, it changes it. It's no longer symmetric about the origin, but when I take that constant off, now it is symmetrical. Okay, so a function can either be even, odd, or neither. It cannot be two things at the same time. So in example 3, all we want to do is determine whether the given functions are even, odd, or neither. So if we look at A, notice that it is symmetric about the y-axis, which makes this an even function. Okay. Looking at letter B, notice that it is not symmetric about the y-axis, so it's not even. And it's not symmetric about the origin because this does not match this. So therefore, this is an example of neither. Okay. Looking at letter C, okay, this does not have y-axis symmetry, but it does have origin symmetry because this part of the graph matches this part of the graph, and then this part of the graph matches that part of the graph. So that makes this an odd function. Okay, looking at equations now, notice that on our equations, okay, this has a mixture of odd and even exponents. So when there's a mixture, that means that it's neither. If we're looking at letter E, notice that these only have even exponents. And it has a constant, which is okay. So that makes this an even function. And then if we look at this last one, notice that all of the exponents are odd, which makes this an odd function. But remember, if this had a constant on the end, it would be neither. Okay, so that's the end of this lesson. If you have any questions, make sure you write them down and ask in class.